All right, we have problem number 4 from the practice on chapter 8 and nth roots, where we have 12 divided by the square root of 6n, and we want to simplify this because we don't want to have radicals in the denominator of fraction. That's just something that we don't want to deal with. Having irrational numbers and denominators is not something that we want to work with, so we're going to eliminate that. And to eliminate this, what we're going to do is just create or generate an equivalent fraction. And to generate an equivalent fraction, what we need to do is take our existing fraction and multiply the numerator and denominator by the same thing. So if I want to get rid of the square root of 6n, then what I'm going to do is I'm going to multiply by the square root of 6n. And if I multiply the denominator by that, I have to take the numerator and multiply it by that too. So I'm going to take 12 over the square root of 6n and multiply it by the square root of 6n over the square root of 6n, which is just the same thing as 1, but I'm going to change the values in the numerator and the denominator. But I will not change the relationship between those two things, so that's okay to do. So when I multiply the numerator by the square root of 6n, I get 12 times the square root of 6n divided by, in the denominator now, 6n, because the square root of 6n times the square root of 6n is 6n. So I've simplified this. There's no more radical in the denominator, but I can simplify this further because I can do 12 over 6. I have just one term in the denominator, one term in the numerator, so I can do any applicable division there, which is 12 over 6. 12 over 6 is 2 over 1, so this can be simplified to 2 times the square root of 6n divided by n. And that's where we get this answer here. Number 5 here, I believe this is, where we have 3 divided by 2 plus the square root of x. Once again, we have a radical in the denominator, a radical that we can't simplify because we don't know what the square root of x is, so we want to get rid of this radical. To do this, once again, just like the last example, we're going to multiply the numerator and denominator by the same thing, because that will maintain the equivalence of this fraction or the relationship between the numerator and denominator. To get rid of this radical here, we're going to multiply by the conjugate of this denominator. In other words, we're going to multiply by 2 minus the square root of x. And we'll do that in the numerator and denominator. Notice it's not the same exact thing. If we multiplied this fraction by 2 plus the square root of x, then this square root will not go away. We'll end up doing some multiplication, and we'll have 2 times the square root of x in there, which will not be good, which might be something that we might want to try, and it doesn't happen. So we're going to multiply by the conjugate of this, because when we multiply by that, then the square roots will go away or cancel out. So what does that look like? Looks like this. The numerator comes from 3 times 2 is 6. 3 times the negative square root of x is negative 3 times the square root of x. In the denominator, we have 4 from 2 times 2. Then we do 2 times negative square root of x, which is negative 2 times the square root of x. Then we have positive square root of x times positive 2, which is positive 2 times the square root of x. And then positive square root of x times negative square root of x is negative square root of x squared. So now we have these two terms here, negative 2 square root of x plus 2 square root of x, those cancel out. And then the square root of x squared is just x. So the numerator stays exactly the same. There's nothing we can do there, but the denominator can be simplified, and now the radicals are gone. And we have 4 minus x. And now this is as simplified as we can go. We can't simplify this any further. 2 terms in the numerator, 2 terms in the denominator, no sort of division we can do there. So we are done. Next one, number 6, the third root of 2x plus 5 equals 3, and we want to solve for all real values of x. Well, we have this third root. To undo the third root, what we're going to do is take it to the third power. Do both sides to the third power, and the third root of 2x plus 5 to the third power is just 2x plus 5. This 27 comes from 3 to the third power. So we have 2x plus 5 equals 27, and at this point, this becomes a very basic algebraic equation to solve. Subtract 5 on both sides, and you get 2x equals 22. And if 2x equals 22, then x has to be 11.